Okay, today we are talking about vectors, adding them, subtracting them graphically, how to resolve vectors into their components along different axes, and how that's useful to add them together. So, we did this before in Unit 1, but in that case we were only adding vectors along a single line. So now we're going to start doing that in 2 dimensions. And I'm not sure that we talked about this word resultant. So that just refers to the sum of any 2 vectors. It doesn't have to be a displacement vector. It can be a velocity vector or a force vector when we get to that. Okay, when you add vectors graphically, there are rules for getting this correct. So when you arrange them, you need to have the tail, that's referred to like the dot of the vector where it begins, next to the head or arrow end of the vector you're adding it with. Okay, so if you imagine this as a walk from A to B to C, then it's like we're starting at point A, that's an S, so this is the start, okay? And then you can see that we're walking in the direction of from A to B. Then we maybe pause at point B. Then we walk from B to C, we have changed direction, and then we, let's say, end up at point C. Okay. Well, then the resultant of that displacement vector, the overall displacement from that journey, would just be a vector that goes straight from A to C. Okay? And so when you draw that vector, you always put its tail at the start and its head or arrow at the finish. Sorry, I'm going to cough. So you will notice that the 2 arrowheads are on top of each other at the end. That's okay. But the 2 vectors that you're adding together must have the arrowhead of the first one on top of the dot or the tail of the second one. Okay. We're going to practice that together in class. It doesn't matter what order you add them in. So in other words, A plus B equals B plus A. If you're trying to subtract, it's adding a negative, right? And the negative in terms of vectors means direction, or sign means direction. And we've talked about that before. So when you want to subtract a vector, how do you do that graphically? Well, basically you flip it 180 degrees. So here they're showing that here by pointing out that if vector B points up and to the left, then negative B points down and to the right. And so if you want to do A minus B, you can just do A plus negative B. That's how you would subtract vectors. So like I said earlier, you can do this kind of vector math with any kind of vector. So believe it or not, this works for velocity in meters per second, okay? It works for forces later when we get to forces. So, but you can only obviously add vectors that have the same units, right? So, let's do this little quiz question, right? So, it's asking which one is false. All right. So let's go one at a time here. C plus A is equal to negative B. Now I kind of drew my arrows down here because this was a photo I took, but let's try rearranging these. Okay, so what do I get? I'm going to pull B out for a second. Here's C plus A. Are those arranged correctly? Well, yes. The arrowhead at the end of C is at the tail of A, so that's fine. When I add those two, what do I get? Well, then here's my start, right? Here's my finish. And then the sum of those two, let me pick a different color because I like to have this, clear of what. Here's the sum. I draw it straight from start to finish. So is that equal to the opposite of B? Well, yes, that is. That's okay. So that's fine. That's not false. That's true. C equals A plus B. Let's check that. So now let's erase what I have here and check this out. So now I'm checking, do A and B add to C? So now put B back in here, pull C out. Okay, so now A and B are just fine. Here's the start, here's the finish. If I draw a vector starting at this tail and going to the arrowhead of the next one, that would be the sum of A plus B. So actually that is not correct. This looks false. Okay. Now let's just quick talk through the rest. A plus B plus C equals 0. Actually that looks right to me. Okay. Because if I follow along in the original picture, if I start here, I go around the triangle, I'm back where I started. So that is true. That's good. Okay. The next one, D, notice there are no little arrows over those capital letters. So that means they're asking me about the lengths. Okay, they're not asking me about the vectors themselves. They're just referring to the lengths. So they're asking me basically, is the hypotenuse less than the sum of the two legs? Okay, yes, that's true. And then A squared plus B squared. Again, no little arrow signs over the letters. Does the A squared plus B squared equals C squared? According to Pythagorean theorem, yes, that's true too. From geometry, not from physics. All of these are math things, right? So then I'm picking B is the false one. Okay. Then we get into something we call resolving vectors, which is really just putting, kind of pushing up the vector. How much of this vector is on the x-axis? How much of this vector is on the y-axis? So that I can find, it's kind of like breaking down the hypotenuse or finding the two sides of the right triangle that would make this diagonal line, okay? So if I do that, I'm sort of breaking this into pieces. I'm taking a hypotenuse and I'm finding the sides of the triangle that when I add those two together, those two vectors together, I would get the hypotenuse. So the components then, right, you would use right triangle trig in order to find, here's the hypotenuse would be A, and I would use cosine to find the x side and sine to find the y side, but you have to pay attention that theta has to be defined based on its angle with the positive axis. Let me go back a slide. So notice here, they're measuring it with respect to the positive x-axis. So be careful if a problem doesn't give it to you that way. If they give you this angle instead, okay, that one you need to use a different trig function. Okay, so let's, I'm going to skip this one. This is pretty easy. Let's practice this. So, for instance, if you've got a football player and I've got a football field and they are carrying the ball a certain distance and in a direction 76 degrees north of east. Now I'm eyeballing this, okay, in my picture. So I'm imagining that here's my x-axis, here's my east, okay, so here's east. Whoops. It's almost east now. Okay, and that this angle here is about 76 degrees, just so I have a diagram to look at. And then when they tell me the amount of distance that the football player is running, they're telling me the hypotenuse, okay, 33 meters. So then they want to know, find the northward component of displacement. So I'm saying north is this direction, okay? East is that direction. I want to know what is this side of the triangle, basically, okay? I'm trying to find, I'll call it delta y, okay? So if I'm going to do that right, all I'm doing is geometry or right triangle trig. So then I know the hypotenuse, and I know the angle. And I am trying to find the side opposite. So for SOHCAHTOA, I want to use sine. So I'm going to do sine of 76 degrees equals delta y over hypotenuse, which is 33 meters. And so then make sure your calculator is in degrees, okay, since they gave me an angle in degrees, and then I'm multiplying both sides by 33 multiplied by sine 76. I get 32. Is that a surprise to you? Think about it. That does look like it's mostly in the northern direction, right? Because that angle is so close to 90. So that angle, or that amount, should make sense. Then let's do one more. Here's a problem where it says your dog leaves home. Okay, he runs 1.7, let's make this arrow be our 1.7 km east. Then runs north. Okay, I got to turn this arrow. We don't know how far north, right? I don't know. Okay. But it says if the magnitude of your dog's total displacement vector is 2.5 km north, or no, 2.5 km, not telling the direction, what is the direction? Okay. So they want us to find, these are angles here. They want us to find the angle here. Let's draw the overall displacement vector. Pick a different color than red. So here's where he started, right? Here's where he finished. Draw the displacement vector. There it is. Okay, that's the overall. If you were in a car going to find your dog and you could go that diagonal route, you would. That would be the quickest way to go find him. All right, and that is 2.5 km, right? And we're trying to find this angle with respect to due east. That's theta. We're trying to find that. Okay, that's fine, because now that's just trig. I know the length of the hypotenuse. I know the length of the adjacent side. So wouldn't I use cosine? Cosine of theta is adjacent over hypotenuse. Ooh, lordy, this is really bad handwriting. And then you would do inverse cosine of both sides. So then you'd get theta is inverse cosine okay, and I get 40. I get the 47 north of east. Okay. All right.